Hello everyone, my name is Wenting Song. This is my presentation for a project I'm doing for a course image processing and computer vision. The topic of my project is removing moving people from static scenes. The reason I choose this topic is because I find it unpleasant sometimes when I just want to take the pictures of the scenes or the buildings, and I don't want any people in my pictures. So the purpose of my project is to remove unwanted people from multiple images of the same scene taken. I have come up with four methods, which are computing the average value of every pixels, computing the mode value of every pixels, and the median value, and detecting moving objects. I use MATLAB to generate the results taken by three approaches and make comparisons to see which one would give the best performance. So I took multiple images at a building called French Fries in my campus. I take like almost 30, over 30 images, and this is my data set. Mm, but if I simply use these pictures, if I just simply blend the images together without any pre-processing, the images would be overlapped and cannot be used. So it's like this. There are some overlapped edges of the same object. So we need to bring each image into the same projection plane by implementing image registration. So what is image registration? It is a process to find each point in the first image and its corresponding point in other images of the same view, and to spatially align all the images so that corresponding points would be assumed the same coordinates. Let's see an example. This is the A is reference image, B is sensed image, C is image mosaic created by image registration that contains image information of both images. Another example is that the pictures I took from study room. As you can see, the leftmost image is reference image, and rightmost image is the sensed image. The image from the bottom is the mosaic image created by image registration of these two images. Image registration is of big help for overcoming common issues like image rotation scale. I explored two methods of doing image registration, which are mobile accelerometer data and surf feature matching with RANSEC optimization to estimate the geometric relationship between the two images and the change in plane between any two shots. And it turned out that the feature matching gave us better estimate of the homography matrix compared to the accelerometer data. And I used um, uh, an algorithm called SURF, which is based on feature matching. So SURF is speeded up robust features. It has these 5 steps: feature detection, feature point description, feature point matching, mapping relation establishment, and image fusion. The method will find the initial corresponding matching points which has the least distance, which is used after extraction of feature points using SURF. But SURF has its shortcomings. You can see in this picture that there are a lot of mismatching. The reason why that there are so many mismatching is because some points they look alike and the search algorithm cannot detect them, so they mismatch the points that they look alike. So that's one of the biggest disadvantages of the surf matching. That is, it would occur a high error rate of matching. But we can this problem can be dealt with by a method called random sample consensus. That's RANSEC, which is an algorithm for eliminating mismatch pairs. So RANSEC, it has been applied for recursive estimation applications where the input are corrupted by outliers. Inliers are the data which can be backed up by model parameters, though may be subjected to noise. As you can see from this picture, the blue points are inliers. And the outliers are the data of huge deviation from inliers, so it has no influence on estimates. As you can see from this picture, the red points are the outliers. Extreme values of noise in correct assumption of interpretation of dataset would generate outliers. As an outlier detection method, RANSEC can divide a set of data into inliers and outliers and yields estimation from minimum amount of dataset. It is an iterative method, which means that the more iterations are allowed, the more the probability will be increased. Finally, I evaluated the outcomes of the different approaches I take. The first approach is compute the average value of pixels. This would result in ghosting effect. This is because pixel intensities corresponding to moving objects influence the value of the pixel when we take average. As for the second approach, which is compute the mode value of pixels. Theoretically, this should be the best approach since the pixel intensity corresponding to the static scene would occur most for every pixel. Though sometimes, due to slight and noise variations in intensity or the false identification of static background objects such as leaves, snow, rain, shadow, as moving objects. So we are not able to find a mode for a particular pixel, which leaves image with black pixels. And another reason for that is because I just take 30 images. If I have taken a lot of images, like hundreds or thousand images, the mode would give me a better performance than it is now. And the third approach, which is compute the median value of pixel, it gives me the best performance so far. It is due to the fact that the intensity of the pixel in images follow a Gaussian distribution whose maxima is a value corresponding to the intensity of the static scene. And the fourth method involves using motion detection to find out moving pixel and assigning them zero value. Then blending images together to give the final result. Since images are shot at a significant time interval, we were not able to successfully implement this approach using present algorithms. More investigation is required in this approach. Conclusion. So the fourth method I came up with, which is can compute the average value, the mode value, the medium value, or detect moving objects. These can be used with different cases, and all have its limitations and advantages. As for in my case for this project, medium result gives me the best performance without loss in image fidelity. The reason behind the fact is that the intensity of the pixel in images follow a Gaussian distribution, whose maxima is a value corresponding to the intensity of the static scene. So when we take the medium, we would get pixel intensity corresponding to the static scene. And I will show you the code I wrote for this project. This is input all the images I have taken, and it calls homo function. It is here. The homo function is for the image registration, which can put all the images into the same plane. So that is the homo function. And then the three approaches I have taken is the compute the average, mode, medium. That's the average. It computes average pixels of every images. It is mode. And this is medium. Thank you for watching.